Hey guys, so in this video I wanted to go over analog inputs with the Micrologix 1100. And what I'm going to do is start off by talking about the differences between an analog signal and a digital signal. And let's start with digital signals. I imagine most of you already know what a limit switch is. And we're going to imagine that I've got 24 volts hooked up to this limit switch. So what does a limit switch do? Well, a limit switch is going to output a signal. When, in this case, when the arm is up and not making contact, the limit switch will be outputting 0 volts. There will be nothing there. Now, if you were to go over there and press the limit switch down, it would output 24 volts. Now, if you let go of the arm, the signal would return back to 0 volts. There would be nothing there. And you can do this for as many times as you want. But the point here is that the amount of outputs that this limit switch gives off is finite. It can only ever be 0 volts or 24 volts. It can only ever be high or low, true or false, on or off. So that's a digital signal. Okay, so what's an analog signal? Well, for example, let's take a sensor that measures the level of water within a tank. It measures the height. So with sensors that output an analog signal, typically what they're going to output is either a voltage or current. With voltage, it's going to typically be anywhere from 0 to 10 volts, or with current, it'll output 4 to 20 milliamps. There's other variations, but those are probably the two most common. So for example, the sensor that I'm going to use is going to output 0 to 10 volts. So in order to demonstrate that, let's look at a couple graphs here. The graph on the left is going to be mapping our water level in the tank. On the y-axis you can see it measures feet, and on the x-axis it measures time. And then the graph on the right is our sensor output. We'll map that, and on the y-axis you can see it has the voltage level, and on x-axis it measures time. Now, as we fill up the tank and the water level starts to rise, you can see here it's climbed to 40 feet, our sensor output is actually going to go up as well. The voltage will increase. And as the water level in the tank increases a little bit more, then maybe it dips back down because we used it, the sensor output will change with that as well. So as you can see, the point here is that the output, it varies over time. At some points in time, the voltage was at 2 volts, maybe 2.5 volts, 3 volts, 5.25 volts. There's a lot of varying that goes on with this signal. Okay, let's talk about the Micrologix side of things now. So on your Micrologix, you probably have 2 analog inputs that are voltage based. So what that means is that if you were to try and hook up a sensor that outputs 4 to 20 milliamps, it's not going to work. Probably going to need something that ranges from 0 to 10 volts. Now, on those 2 inputs, each one of them has a word, an input word in your input data file. And it's going to utilize 10 bits of that word to give you a value, hence the 10-bit input resolution. That's what that means. So if you look here at this table that I put on here, this is from the data file, the input data file, and you can see here the input 0.4 and input 0.5. Those are my 2 analog input words, and I've highlighted the first 10 bits of input 0.4, the one that I'm going to use here in a second. So you can see bits 0 through 9 that are highlighted. Those are the bits that are going to form a value for you ranging from 0 to 1023. Now, what do we do with that resolution? Well, we take that resolution and we scale it to a desired unit of measurement. And I'll show you how we do that. Before we jump into RSLogix, just wanted to quickly show how I've got it wired up, or how it would look. The red wire is going to be the signal wire, the output wire off my sensor, and that is landing on IV1, which is my analog input 0. And then you can see also that both these analog inputs have a common, which is the black wire that needs to go back to your negative or your ground. So, Okay, so here we are in Micrologix, and go ahead and disregard this coil that I have here. I just guess I used it as a placeholder. But after we have wired up our sensor to our PLC, what we can do is come over here to our input file. And you can see here, if you expand this a little bit more, you've got I0.4, which is our input 0 of our analog input 0. Now you can kind of see I've already got it turned up. What I have here is a little voltage simulator, so I'm just sourcing 10 volts here manually. And let's see if I turn it down, you can see all those bits changing there. And if you wanted to convert those to decimal form, you could, but all you have to come over here is to this Radix drop-down menu and select decimal, and it converts it to decimal for you. So I'm going to be honest with you, I don't know why when there's 0 volts applied, they default to the value of 4. Because when I read the documentation, I believed it said 0 to 10,000, or excuse me, 1023. So I don't have an answer as to why that's reading 4 right now with 0 volts. Anyways, as I turn my sensor up and apply more voltage to it, you can see my values are increasing. It'll go up, up, up. And normally, if I applied 10 volts to it, it would go all the way up to 1023. This little voltage simulator that I made, for some reason, when I hook it up to the PLC, it's only outputting about 9.4 volts. So that's why when I turn my simulator up all the way, we're only seeing 1003, 1004. So don't let that confuse you. That's just something on my end that happens. So, okay, so we know our input is working. We see the value changing over here. So now we want to actually scale that to a usable, I guess you could say, usable unit. That way we can display like feet or pressure or whatever you decide to do or need to do onto an HMI or whatever the case is. So let's, what we're going to do is come over here and we're going to find, if I can remember, I think it's an advanced math and the SCP here, scale with parameters. If it'll go. Okay, let's see. Oh, I'm online, so I probably need to do that. Okay, there we go. We'll delete him. And okay, so scale with parameters, SCP instruction. So first of all, you have your input. Our input is obviously going to be I0.4. This is what we're reading from. Okay, then our input minimum, say 0. Maybe I should put 4 since it's reading 4 at the minimum for some reason. Input max, that is going to be 1023. Okay, now here's our scaled values here. So let's say that 0, let's say we're doing feet. Okay, so we'll have scaled minimum will be 0 feet. And the maximum, let's say that our tank goes up to 500 feet. Or let's say the pressure of your pressure sensor, the maximum it goes is 200 PSI, right? So if it was giving off the full or the max amount of voltage, 10 volts, that means you'd have the maximum amount of feet or pressure or whatever. So let's just say 200, okay? The output is going to be, you need to send that somewhere. So we can just use an N7 bit. So we'll say N70 and press OK. Cool. Let's see, we'll verify it, accept it, test, and assemble. Okay, cool. Let's get some live action going on here. So go ahead and pay attention to this value right here. This is going to be our input. This is our I guess you could say, our raw value. This is the bit value, and as I turn the voltage up, you can see that value increasing. Okay, I'm going to go ahead and turn it back down all the way. Okay, now remember here where we scaled, our minimum is 0 and our max is 200. So this is going to scale this raw input to a value between 0 and 200, and it's going to put it here in our output, which is sending it to N70. So as I turn it up, it's at 0 feet or 0 psi, whatever your use case is, you can see now, for example, if the voltage stopped there, it would be 22 psi or 80 psi or 130 psi, or whatever it is you're trying to do. And again, mine's only going up to 196 because my little simulator that I'm using only outputs a maximum of 9.4 volts right now, or 9.6, because I screwed something up. But regardless, this should give you a pretty good idea of how to work with analog inputs and how you scale them and how you can use it in your own application. Before I end the video, I just wanted to put out a quick disclaimer. My videos really are just meant to give you a high-level understanding of these topics that I go over. And so the example I gave with measuring your tank height in feet with the sensor, more than likely it's not going to be just a matter of plug and play. You're probably going to have to do some additional math based on, the diameter of the tank, or the, whatever the case, if there's a cone at the bottom. It probably wouldn't be just a simple plug and play like this. Again, this is just more to be like a high level understanding of how you can take analog input and scale it to something or a value and use that. So yeah, and I just hope this video helped some people out and made it simple for you. And yeah, thanks for watching.